So we'll start with the first presenter, Francis. Please tell us about the excavator. You have 5 minutes.
Yeah, thank you, Nelson. And greetings to everyone from North Carolina. I'm showing here actually the names of our entire team, and that's pretty much the entire team at NC State University working on pit emptying. And of course, since I'm the first speaker, I wanted to show the sanitation chain and to emphasize that our project is looking at the storage and collection, basically the emptying of pit latrines. So this particular portion here that's shown in red. And the problem of pit emptying can be captured in these two pictures, and one is from Burkina Faso, from Florian Erzinger, and it actually is quite a famous picture now of manual pit emptying. And the photo on the right was taken by Dave Still in South Africa, Partners in Development, and I hope you can see the man who's in there and down in the pit, and he's wearing a face mask, but otherwise he's not wearing any protective clothing. So if you start thinking about those issues, the Gates Foundation had the RFP out, and so under the Grand Challenges Exploration, had these criteria for a pit emptier that, or emptying technology that would satisfy all these criteria. And in particular, we're looking at hygienic pit emptying, and that is robust and can remove heavy sludge or debris from the bottom of pit latrines. And of course, it's got to be something that can be made locally and affordable. So our project was this pit screw auger that we now call the Excrevator, and I'm showing two schematics here. The one on the left is a rendering. That's how it looks like. And it's basically an auger or a screw auger inside a tube. And you stick the tube into the pit, and you rotate the auger so that the waste is moving up on the tube, and then it's essentially transferred to a collection vessel. And it can be a drum, or it can be, what type of collection bucket that you may have. So this is now version 3, and in this version, we have a dolly, which is attached a hydraulic motor, and that's powered by a gasoline engine in version 3. And on the right is a picture of our field testing unit, and that's the one we have in the lab. It's a very simple machine. Essentially, you just need to supply power so that you can rotate the auger and lift the waste up. The nice thing about this machine is that the hydraulic motor allows it to rotate in a reverse direction, and that is important. When you have jamming, you can actually push the waste down. So we've done a lot of lab testing, and in the lab, I'm going to show one graph. Basically, what this is showing is that it needs a certain rotational speed, but as you increase the RPM of the auger, you get an increase in the flow rate. And also, you can notice here that the higher the solids, the better it performs. So that's actually a big plus, depending on the sludge that we're looking at. In the lab, also, we've shown that typical flow rate would be something like 50 liters per minute. And what that means is that we can empty a 1 cubic meter pit in less than 30 minutes. And again, this photo is showing the bentonite mixture, just to show you an example of what it can pump. And in the field, we've done this on cow manure at a dairy farm here at NC State. And the solids content of that particular manure is around 20%. So you can see it can go pretty high, and it's pretty easy operation too. In March last year, we were able to test this in South Africa, and this is version 2 of the auger, slightly different design, but same principle, being used by workers just outside Durban in South Africa. And we show that it can work. There are some kinks that we have to address, but basically this type of pit can be emptied. the issues that we saw in South Africa, include things like this. You have all kinds of trash, all kinds of solids that can be present in these VIPs. So this is a challenge that we're trying to address right now. So one of the things that we've realized is that we really need to characterize and quantify the different kinds of sludge and the different kinds of pits that are out there in different countries. So for VIPs in South Africa, we're talking about really high trash content, really high solids, and also the presence of layers. There can be hard layers and then can be watery layers inside the single pit. So we have to make sure that we can address all of those layers and empty the pit out. One of the things that we're interested and excited about is the use of a penetrometer, and we've been talking and working with Jamie Radford, who's developed a field penetrometer that we could use. And the idea is that people around the world can start characterizing the sludge, and in the end, we can match the pit emptying technology with the different sludges with different characteristics. The next steps for the excavator is to basically, we're working on addressing the mixing issue and addressing the trash issue. So we have different versions going on in the lab right now. Next month, we're going to India and test this on septic tanks with hard compact layers at the bottom. We have a partner there that's interested. And then as part of the Gates grant phase 2, we're going to test in Malawi at Mazuzu University in June, and also going back to South Africa in July and August. And we're looking at potential partners in Zambia and Kenya. And we're hoping that by 2015 we can scale this up. So I think that's my 5 minutes. That was quite quick. But I hope everybody got an idea of our project. And we'll be happy to answer questions.
Thank you very much, Francis. Very great presentation there. Very interesting machine. So we open the floor for questions now.
Question for Francis. With respect to solid waste, is that something that is a routine? I mean, there is so much solid waste in pits that these things are not really designed normally for unusual kinds of solid waste. So what sorts of challenges in designing this thing have you had around the unusual things that you can find in pit latrines?
Right, and as you saw from the pictures, there are all kinds of things that can be in there. Plastic bags, newspapers, of course, are used. You can see all kinds of rope. Clothing can be in there. Anything that you can imagine that people can throw down the pit. And of course, education and trying to reduce the sludge, the trash in the sludge, is something that is always a positive, and something that for example, Ekane municipality in Durban is trying to address. But our machine, we feel that once it enters the auger itself, we can actually push it up. And we're working now on versions where we have a way of cutting the trash before it comes in. So we're really excited. We have some new designs that we're testing in the lab right now, actually. And the idea is to cut and use the power from the hydraulic motor, the same rotary power, to slice materials before they actually get into the auger. We've done some initial testing with rope, for example, and you see that depending on the dimensions of the rope, we can actually pump it out. So we're hopeful that we can handle some of the trash. Obviously, there are kinds of trash that is probably not possible to empty. But if we can leave that in the pit, then it might be an easier task than just manually taking them out. But
okay. Thank you, Francis. Yeah, I see Elizabeth has something. Elizabeth?
Yeah, thanks very much for that, Daniel. I think it's really fascinating that this topic of fecal sludge transport is now being researched at a university level, not just by people in the field, which is also important. So I'm just curious, what is it like for you as a professor in the States when you're doing research on this? How difficult is it for you to convince the students or your other professors that this is really important research, and what academic twist can you give to it in terms of the auger? Or I can imagine that there's some challenges there with just doing it as an academic, this sort of research.
Well, as academics, our currency is papers and results. And the more we get into this, actually, the more we realize that there's a lot of knowledge gaps that we have to address. So it's one of those things that as you dig deeper, sorry about the pun, you actually find out that it gets more exciting. So it's a combination of thinking about mechanical properties as well as about thinking about operation and then design and then thinking about how people would use it. At the same time, keeping everything, the costs down. So all of those things come together and it becomes quite challenging also. In terms of students, they, as probably everybody knows, a lot of students in the US are actually really interested and excited to do work like this. It's not glamorous work, but I think that's part of the excitement for them. Our main challenge, actually, sorry, Nelson. Our main challenge is, we're in the U.S. and it's hard to simulate, things like this, like the trash content that you see here. So the key is to actually go out in the field and iterate in the field, and that's what we intend to do this year. And the other thing is, how do we quantify and standardize, for example, trash contents? So a few people are working on that now. For example, our collaborators at UKZN, Peace Bucket Group, is looking at how to come up with a typical trash level in VIPs at least. It's also going to be different in India. It's going to be different where you have 4 flush toilets and so on.
Thank you, Francis. We have several questions coming up. Brian, you have something, and Mutala, we may take just those 2 for now.
Yes, Francis, I was just wondering, we've got several groups that actually have challenges to do the cutting on the input solid waste. I'm wondering if NCSU would be open to collaboration on that front, since I know that our group and others, I think, would have an interest in trying to come up with best practices with respect to cutting technology for input to augers.
Oh, sure. Of course, Brian, we're open to collaborations. We now have a new design that Tate and Walt in our team are testing in the field, in the lab, sorry. And we feel that we can harness the rotational motion and the power of the auger to do that. And we're going to test these designs and iterate through them, but we're always open to to collaborations. And hopefully by the time it gets out of the auger, the trash would be smaller pieces, obviously, and also the sludge would be a little bit different quality, because we know that once you input energy into it, the characteristics of the sludge also change a little bit. So yes, we're open to collaboration.
Okay, Mutala?
Okay. Francis, thank you very much for the presentation. I'm happy to have worked with fecal sludge in Africa, back in Ghana. But as you pointed out earlier on, one of the challenges has to do with the segregation of the sludge, whereby you have a lot of people in the household using all kind of materials, putting into the septic. In Africa, the kind of system that we use, the septic tank system. So I don't know how, it's actually one of your challenges, one of your major challenges in trying to come up with this technology in the segregation of the fecal sludge, whereby you have the sludge going out and you have the liquid aspect also coming out. But from my experience, what I've realized is that in working with fecal sludge, even when you go and take samples, to kind of like analyze, you end up with all the fecal sludge being contained with all kind of substances. So you don't really get the quality of the fecal sludge that you need to do your analysis. So I want to know how best you are trying in terms of coming out with this technology, how best you'll be able to address this problem.
For me, I couldn't hear part of the question, but I think you're asking if the solids and all of the different things that people throw down the pits are problems for the excavator.